Hello, welcome to Go Tutoring. Today we'll be looking at trigonometry. Let's dive in. In our first lesson, we'll be looking at what is trig specifically, explaining what the ratios mean, sine, cos, and tan. We're looking at a very simple mnemonic that you can use to memorize the ratios, namely SOHCAHTOA. Then we're going to go through some problems that we can sort of apply our knowledge to. And at the very end, I'll be leaving you with some additional problems that I will give solutions to in the next video. So let's dive right in. What is trigonometry? So firstly, we begin with a right angled triangle. Now, a triangle is any shape with three sides, like so. And trigonometry applies to a very small subset of this triangle, namely right angled triangle. This triangle is right angled because of this 90-degree angle at the corner. I've also labeled here two angles, alpha and beta. These are Greek letters that are usually used to denote angles. I will also be using the side length B as this side here, and A as this side here. This side we can call C. Okay, so what does trigonometry do? Well, trigonometry is quite interesting because it relates the ratio of the sides with the angles. Okay, so let's first just look at how many ratios can we even make. Let's see. So we can take the ratios of C divided by B, C divided by A, and the flips of these guys. So B over C, A over C. Let's see if we missed any. A over B and B over A. As it turns out, which is a pretty interesting fact, these ratios of any triangle have deep connection with the actual angle the triangle has. Pretty mouthful. So what this means is for any triangle that you can make, these ratios will tell you in some way what the angles have to be for this ratio to be true. In fact, for this very reason, we are able to describe a triangle using both angles and sides. So, if you understood this part, you're pretty much halfway there understanding trigonometry. So, let's see what ratios we can make. So, when the people who came up with trigonometry, they sort of decided on a set of these ratios to be, I guess, the more placeholder ratios. These are known as sine, cosine, and tan. Now, we usually abbreviate them. So cosine is usually written as cos. Its full form is cosine. And tan is actually called tangent, but is abbreviated as tan. Okay, so let's look at what each of these mean. So sine is like a function, like addition or subtraction. It takes a function, it takes a variable, for example, alpha. Alpha is an angle, and this turns or it results in a ratio. So in this case, this is how we define the ratio. Sine is described by the division or the fraction opposite over adjacent. In other words, the side that is opposite to the angle divided by the hypotenuse. So this side, the longest side, is called the hypotenuse. Okay, so sine of alpha would then just be A over C. Okay, similarly, cos of alpha is given by B over C, adjacent over hypotenuse. So this B is adjacent to alpha, so we simply do B over C. Similarly, tan of alpha is a little different. For tan of alpha, we do opposite over adjacent, A over B. Now, these ratios are sort of fixed That means that for every triangle, you can always find sine of any angle that is given by the side that is opposite to the angle divided by the hypotenuse for the sine of that angle, and so on and so forth for cos and tan. Let's take a quick look with an easier diagram. Sort of, we look at this. So if you have any angle, say alpha again, this side is the opposite, this side is the adjacent, and this side is the hypotenuse, which means sine of alpha is opposite over hypotenuse. In other words, so. So you should remember so. So just means sine is given as opposite over hypotenuse. Similarly, cos of alpha is given as adjacent over hypotenuse, which you can see here. C-A-H. In other words, ka, like a ko, maybe. And tan of alpha is given as opposite over adjacent. Toa. So, ka, toa. Say that 3 times and you have already mastered most of this memorization. Okay, now let's take a quick look at the implementation of this. So here we have a triangle, right angled, alpha, beta, and we'll label these sides some arbitrary values, 5, 4, and 3. Now, if I asked you to find sine of alpha, what would you do? Well, you would say, you remember, so opposite over hypotenuse. And you look at the angle, and so this angle tells you which sort of reference you're looking at. So the opposite to alpha is 3, and the hypotenuse is going to be 5. So sine of alpha is, well, O over h, just to sort of remember, which means it is going to be 3 over 5. Usually we don't have to write this stuff, so we can just say sine of alpha is 3 over 5. So try doing it for cos of alpha and tan of alpha. Take a pause here, try these. Okay, so cos of alpha would just be, we would remember, ka, like a crow. So adjacent over hypotenuse, 4 over 5. Tan is toa, opposite for adjacent, 3 over 4. Okay, now here's a bit of a problem that we're going to solve in the next video. Look at these 2 triangles. So we have these 2 triangles. There's like 60, 30, 2, 1, and 3. Let's make another one. 5, 45, 270 as well. This is root 2, 1, and 1. Your job is to find, let's start with sine. So sine of 60. When I just write 60, I just mean degrees. So sine of 60 Okay, so thank you for watching and see you in the next video.